Hello. Today I'm going to introduce this concept of Analoguino, which is analog in and intelligent out. And how are we going to achieve that? Well, we're going to have a bunch of analog signals, a bunch of analog processing, and we're going to try to reconfigure that analog processing on the fly. And how are we going to achieve that? We're going to achieve that with the help of the FPAAs from KiCad, and I'm going to show the versatility of using the FPAAs with different types of microcontrollers. One flavor with the ESP32 and another flavor with an STM32H7. So the FPAA from KiCad that we're going to use is going to be the 231E04A. It's a switched capacitor field programmable analog array. It has 4 cabs, a bunch of I/O ports, the ability to change the clock of these switching capacitors, SPI interface for our microcontrollers, lookup tables, and a bunch of analog cams that we can use and play around. Alright, so all the designs for these boards are available online, and let me show you where you can find that. So over here on this webpage, engredu.com, I have everything available, so from introduction, prototype design, and then schematics, layout, and 3D render, so you can see the board and move around and see how the board is going to be, and an interactive bill of materials. Once the board was done for one microcontroller, then it was kind of pretty much the same to go over an iteration of it using the STM32H7. So kind of the same thought process, everything for free. You can dive into the schematics and change it according to your own design. Alright, so I wanted to say thank you to PCBWay and KiCad for sponsoring this project. PCBWay sponsored the PCB boards and KiCad sponsored the FPAAs. Here you can see the boards and the microcontrollers and the FPAA that I'll be using, and PCBWay also provided the stencils for the STM32 and the ESP32, so I can apply the solder paste. Alright, so let me move on. This video just shows on how I apply the stencil and the solder paste. I first like to clean the boards with isopropyl alcohol 99%. I'm going to move forward so we can see just a snippet of these videos. Alright, then I have this jigsaw. It's pretty cool. Found these designs online, 3D printed, and bring the stencil and align things accordingly. You see me there struggling. Once things are aligned properly, you just screw everything, and then you pick up solder paste. And I actually place 2 rows of solder paste. I recommend probably using a bucket of solder paste, so you can then the excess you can put it back. I'm using a different type of like syringe, so unfortunately I need to, when I'm cleaning, I need to waste the excess. Alright, so I'm just making sure that I have everything ready. Typically I use gloves also for these, but I'm trying to be careful so I don't touch the solder paste. Then around 45 degrees you apply, you spread that solder paste. Alright, and then to remove the rest, just go in a different angle and then lift carefully the stencil, and we're able to remove the PCB board. Need to find a little bit of plastic there to help me, and here you go. I'll put the board there. We'll see the results later. Alright, and then I repeat the same process for the other board. So I actually soldered both boards at the same time. So you see, going through the same process. Apply the stencil, solder paste, and then squeeze everything. Carefully lift the stencil, remove the PCB boards, and then remove everything. I like to clean the stencil right away so the solder paste doesn't stick to the stencils. And then I put the stencil back into the cardboard. Alright, after everything is done, I like to go and confirm if everything is properly placed. Alright, so let's put under the microscope where I can go a little bit with more detail. You can see the microcontroller pads are fine. Then over the FPAA, also good. The USB is a little bit too much solder, but we can fix that by hand, and the ESD also. And then I also confirm the ESP32 pads, and everything is good. If for some reason it's not, we need to clean it and apply the solder paste again. So ESP32 good, FPAA also good, USB and ESD, electrostatic discharge diodes, also good. Alright, then after that, this is a longer video. I'm just going to, it's an hour and 25 minutes. It's literally placing the components. Then I just go over the bag. I have this nice vacuum pump, and I have the bill of materials open and slowly place the components into the board one by one. Let's see if I can capture one. So place the FPAA, place the decoupling capacitors, all of that stuff. Alright, I'm placing components on both boards at the same time. Alright, I don't have a pick and place machine. Make sure everything is aligned. There you go, putting the USB 22 ohms, I believe, resistors for the USB pins, and then confirm if everything is fine, and then reflow. So I have here the reflow profile. I have this cheap heat plate, $50 or $60 from Amazon. I place the boards on top, turn it on, and then I do the reflow by hand. So just place those numbers, let things kind of stabilize, preheat, then do the soak stage, and then the reflow, and then the cool down. Alright, so I go over all of those stages by hand. I just follow that, and eventually when we go up to the reflow zone, when you start getting close to 180, you start seeing things reflowing. It's a little bit hard with this view, but things start soldering. You can kind of see actually the fumes coming out, and I have this fan turned on, absorbs all the fumes. Alright, so after around 30 seconds in the reflow zone or stage, then I turn off the hot plate and I remove the boards from the hot plate. So you can see me turn it off. Here you go. And then remove the boards. Need to be very careful because the components are still on the board, kind of, they can still move. Putting them on the table, or putting the board on the table, the PCB board, and then remove the other one. Alright, so after the reflow is done, then I go on the microscope, bring the boards. They're still a little bit hot. on the microscope to see if everything is fine. Alright. And as I go and I pay attention to what needs to be fixed, kind of see if everything is in place the way that it should. Alright. And then after checking the boards, let's fix some issues. So the USB pins, some of them are short circuit, so you can see me now going and fixing the pins accordingly. Yeah, flux is key here. Securing the board, sometimes I struggle to do that. Here you go. Yeah, no, you get the idea, right? Securing things, touching, going over the pins of the FPAA. The YouTube channel, Mr. Solder Fix, is great to get some pointers on how to do these by hand. Alright, fix FPAA, the op amp, the STM32. So kind of go over all of that, deal with the short circuits, and pin by pin. I touch the LEDs, or in this case also the crystal, the oscillator for the STM, and then I put some 90% isopropyl alcohol, and with a very gentle brush, this is a kid's toothbrush, I go around and remove all the extra flux that I have on the PCB board. Try to clean as best as I can, and if it's still dirty, you can repeat the process through 3 or 4 times until it looks better, or it looks good. So I did this for the STM32H7, and also repeat the process for the ESP32, fixing the USB, touching some pins, capacitors, resistors. Alright, and after everything is good, so let's see the final results. And we have here the boards. So this is the Analoguino with the STM32H7, and this is the FPAA with an ESP32. Alright, so I forgot to order some of the switches here, so I can program the STM using the USB or the SWD pins. So this is a temporary kind of fix that I did with just a pin out, so I can move the jumper around so I can program this board. And I also run out of components, and the 10 picofarads for the Rauch filters, one of the Rauch filters is missing that, but we can still see things working. Alright, so let's do a firmware test. So the first test that we're going to do, it's going to be the blink LED on our ESP32. So let me get things here ready really quick. Let's move to here, the code. So I have, let's actually first power our ESP32. Alright, great. Let's go back to the computer. And I have here the code, program the ESP32. So make sure that you pick the right ESP32. I'm using the ESP32S3 and the right COM6. And here let's have the LED blinking, save, and program. And hopefully we're going to see the LED blinking after the program is done. Alright, compiling. Here you go. Alright, and LED blinking. Great, so this board is up and running. Let's do the same thing for our STM32H7. Let's have the LED blinking. Alright, so for that, I'm not going over how to create a project. I will leave that for a different video. But pretty much I'm using the STM32Cube MX to create the project. We choose the STM32H7, and then I put the pinout accordingly to the schematics. And I have a user LED on PB6. And we set also the clock to be at 280 megahertz. Select your project. Where do you want to save? Generate code. It's going to generate an STM32Cube IDE project. Then I'm using the AJL to have a blink LED. I'm going to press the hammer to build the project. Here on the hardware, let's swap to our STM32. Okay, there's one. Plug it. And I have the jumper here. I'm going to put these into our USB mode. Press reset. So I can program over the USB. Zoom in here. Alright, so I already compiled. So that is a file called ELF file. That's the file that we're going to send through our STM32Cube programmer over USB. So if I refresh here the USB, detects the USB of my STM, connect. Then on the programmer, I just point to that ELF file, which is my template, and then I program the board. And now to make it work, if I go here, switch the jumper to boot from memory and press reset, and you can see the LED blinking. Alright. So boards are up and running. So now let's do an example with the ESP32S3 using an analog comparator. There are 3 flavors on the analog comparator. I'm going to use this one, comparator to signal ground. In our case, the signals on the FPAA are from 0 to 3 volts. So our midpoint is 1.5 volts. So let's see that example. So I go back to the hardware, and I am going to prepare here the boards. So we don't need this one anymore. And so we have these 2 boards, and I have 2 additional boards. That's why I run out of components, where the pinouts are already soldered. Okay, I didn't solder on these ones because I just placed the components, and I wanted to make sure that everything was up and running before I waste material or connectors. So these are exactly the same boards, but now with the pinouts. So I'm going to use the ESP32, and I'm going to connect these over here. And what else are we going to use? I'm going to use the waveforms, Analog Digilant, or Analog Discovery 3 from Digilant. And let me just plug these here. We don't need it. But it gets out of the way. I have a bunch of wires over here, so I'm going to use the software from waveforms, generate a single waveform that enters the single end, goes over the comparator, and then creates a square wave out of a sinusoidal waveform. Okay, so the first thing that I'm going to do is to connect the ground. Let's be a little bit safe here. Let me actually turn off the power of the FPAA for now. And let's connect the ground to my ground pin over here. Alright, then I have my waveform 1. I'm going to have the waveform connected to these boards, so I can monitor the boards at the same time. This enters signal 1. Then I have here oscilloscope 1. That monitors my waveform. And oscilloscope 2, getting a little bit tight over here, that connects to my output. All right, cool. So let's power it up. And my ESP32 is connected. Everything seems fine. And okay, let's go back. So this is the waveforms. I have here a 1 volt amplitude, so 2 volts peak to peak, sinusoidal waveform. And we can start these input output. And right now I have something programmed on the FPAA. We're going to change these. So let's do that program. So let me show you how to do that really quick here. All right, I apologize. Cool. So I have a template. I'm going to copy that template and call it Comparator example. Okay, double click, open that. So that template has already the pins, the input cells ready for the Rauch filters. So we want the comparator, right click, insert new cam. Let's find our comparator. It's this one, place it. I don't need to change anything here, run it as fast as possible. And let's connect that to the input and this to the output. All right, cool, save it. Different ways of programming the FPAA, at least 3. We're going to do the state driven. I have videos and I'll post them on comments so you can follow. Let's do the state driven method. And I'm going to say that I want to pick up the FPAA 1. It's the only one that I have available. It's going to be the one that is going to program, will have the primary state. And let's generate the header files. Generate. All right, cool. I'm going to open the program that I have. So I have this S32 comparator. It's ready to go. It has the LED blinking to make sure that everything is fine, and is looking at the FPAA.config. All right, so let's go grab that configuration. So the output of that generation of Analoguino Designer comes into this text file. I'm going to copy this and place it into the .h file of my program. All right, perfect. Let's connect to our ESP32. Let's pick the correct ESP. And let's program. And hopefully we'll see the LED blinking. Let me put waveforms. And the minute that he programs the boards, hopefully this becomes a square wave. Here you go. And boom, square wave. Up and running. We have the LED blinking. And we have a sinusoidal waveform become a square wave. All right, so what we have coming soon, some shields. So let me show you some of the shields that I am working at. So if we keep scrolling down, some of the shields that are coming soon. First one is the interface shield. So instead of using these cables that you just saw interfacing oscilloscopes or sensors, we can just connect this shield on top of our Analoguino, and we have either SMA connectors or 3.5mm connectors, or just connect directly to the pins. You have 3 volts and minus 3.3 volts available, and also access to the analog pins of the ESP32 or the STM32H7. Another board that is coming soon is a synth shield. So it has stereo or mono audio in and audio out. And you have MIDI in. You have a small STM32F, I believe it's a 303 or a one of those, I forgot. Anyway, it's an STM32 that is going to interface the pots, the LEDs, and the buttons, and MIDI. And then it's going to send that information over UART to the Analoguino, to the S32 or the STM32H7. And you can do a bunch of synths, analog synths with this. Alright, that's all I have, and hope you like it.